Hello, grade 10s. Today we are going to be checking the practice you had to do in your own time or in class. I want you to be on page 11 of your booklets now, and I want you to have a different color pen and mark your work step by step. Make sure that you have every single step under the little sections for each question. The first question asks, calculate the number of moles in 12 grams of sodium oxide. So the first thing you're going to do is write out your formula. The second thing you're going to do is you're going to calculate your molecular mass. And the third thing you're going to do is you're going to apply your default mole formula. In this situation, it's pretty straightforward. There's no tricks or curveballs. It's literally 12 divided by 62, and you should get an answer of 0.19 mole. Question 2 asks you to calculate the number of moles present in 18 grams of carbon monoxide or carbon 2 oxide. So here they've used the stock notation to write out the compound. If you have followed the rules and you follow the chart, you'll be able to figure out that it's carbon monoxide. So it's literally just CO. From there, what do? We get our molecular mass. And then we just calculate the moles as per the default formula. Plug and play, grade 10s. It's really straightforward. Please bear in mind that you need to say there 0.64 mole. If you do not write the unit, once again, we are going to remove a mark. Question 3 was a little bit tricky, I think, for some of you, because here we are requiring you to manipulate the formula. You've got to play with that formula. It's not asking for the moles, it's asking for mass here. So what is the mass of calcium carbonate? That makes up 4 moles of the substance. So it's asking for the mass of the calcium carbonate. You're going to write out your formula, CaCO3. It's pretty simple. Then you're going to write down your molecular mass, which should be 100 grams per mole. And then you are going to just manipulate that formula a little bit, because mass is going to be equal to moles multiplied by molecular mass. And you should get 400 grams. Page 12 follows on with more calculations. At the top of page 12, you see question 4. Now, this is got a little bit, there are more steps involved here. Now, guys, this is an example of what you get in a test or an exam. We're not going to ask you a straightforward mole calculation. We're going to ask you something for concentration or volume or number of particles. What is the concentration? That is I'm using the term essential question now, given the current situation in our country. What is the concentration of a solution of 30 grams of copper nitrate dissolved in 500 centimeter cubed of water? So now there's a lot of things going on here, grade 10. The first thing I want you to do is write out your formula. Make sure you write that formula out properly. The second thing I want you to do is make a note that you have to convert to dm. You have to convert to decimeter. Then make sure that you write down your molecular mass. What is my molecular mass? And for this compound, it's 187.5 grams per mole. First step is our default mole formula, and you should get 0.16 mole. Why do we have to do this first? Because for you to use your concentration formula, you need your moles first. So calculate the moles, and then the last step, because that is my essential question, is the concentration. So you literally plug and play, bearing in mind that you have to convert to decimeters, okay? And you should get an answer of 0.32 moles per decimeter. All right, the next question is question 5. And I like these type of questions because they make things a little bit scaffolding question. You have to do a lot of things before you get to your final answer. Which of the following has the greatest number of particles? So what they're asking here is the number of moles. They want to know, is the chlorine gas going to have more moles than the hydrogen gas? Yes. So greater the moles, the greater the particle. All you're going to do is plug and play with your ordinary mole calculation, and you should see that B has got more particles. So the hydrogen gas has got more particles than the chlorine gas. Okay. Question 6, which is here on the side. It's a little bit small, but hopefully you can see it on your screens. It says here 2 moles of an unknown diatomic gas, so there we go, there's your first clue, has a mass of 64 grams. Identify the diatomic gas. So once again, you have to work backwards. You're going to use the information you have. You have your moles and you have your mass. Okay? So now you need to work out your molecular mass to figure out which gas this is. Sorry, the dogs are a little bit upset. They want some attention. All you're going to do is figure out your molecular mass, which manipulate your formula. You should be getting 32 grams per mole. Divide that by 2, because you know what is a diatomic molecule, grade 10s? It means there's 2 atoms. So you have to divide it by 2. Therefore, it has got to be oxygen. It has to be oxygen. Let's go now to page 13. And at the top of page 13 is question 7. And in my instructions from the previous lesson, I said to you guys, you just need to change that centimeter cubed to decimeter cubed. So you don't need to do any conversions here whatsoever. The thing with this question here is you need to work out the mole first to work backwards and get the mass. And when you're working with gases, you have to use the gases only formula, grade 10s. So the first thing I want you to do is use your gases formula only, okay? Therefore, you don't need to change anything. It's just going to be 224 divided by 22.4 because that is what gases are at standard temperature and pressure when we are looking at molar volume. You should get 10 moles. Next thing you do, you plug and play, you put that 10 moles into your default mole equation, and you should get a mass of 320 grams. Question 8. Yeah, this is a very nice question. This is a nice way of double checking your understanding of that magic number, which is 0.02 times 10 to the 23. It asks how many moles are present in 9.8 times 10 to the 12 particles of substance. So we go back to our formulas when it comes to particles and atoms and molecules. Those extra little particle formulas that we gave you, or equations that we gave you. All you're going to do here, literally all you're going to do is you're going to divide that value by 1 mole, which is our magic number. And then after that, you should get your answer. So it's pretty straightforward and simple, but a lot of kids or a lot of students, when they read this, they're like, how do I do this? What do I do now? They go blank. So just bear in mind that those particle molecules and atoms, that little extra that we gave you after we gave you your mole equation or mole formulas, those are quite important. Those are not, we didn't just give that to you for fun. Another example of a comparative question is question 9. So it's exactly like the previous one that we did with the hydrogen and the chlorine. It's asking which has the greater number of moles. And once again, this is just a plug and play with the default mole calculation for mass. Remember, everything has mass. You need to write out your formulas properly. for aluminum chlorate and for sulfuric acid. You need to work out your molecular mass, and then from there you should see that you are going to have, there are going to be a greater number of moles for your sulfuric acid. So just double check your answers quickly now, pause this, and then I'm going to carry on to the next slide. Question 10 on page 13, so we're almost there, grade 10s. Question 10 says a flask contains 0.85 grams of ammonia, which is NH3. What volume does this occupy? So my essential question is, what volume does this occupy at STP? So what am I going to do first? You're going to write down your formula. What am I doing second? I'm going to write down my molecular mass. What am I doing third? Third thing I'm going to do is I'm going to work out my moles first. So let's work out the moles. Then you're going to take that mole value that you get, which should be 0.05, and you are going to apply it to your gases only formula. Gases only formula. So because you were given a mass amount in the beginning, you can work out that moles first, and then apply it to the specific specific gases only equation. At the end of the day, after you've manipulated everything, you should get an answer of 1.12 decimeter cubed. Okay, because it's asking for volume. Okay, so on page 14, these are the last three questions. At the top of page 14, there's a question asking how many oxygen atoms are in 100 grams of potassium permanganate. Now, once again, I want you to identify your essential question. It's asking for oxygen atoms in that 100 grams of that compound. So write out your formula, get your molecular mass, work out your moles, and then apply that to your atoms formula. And remember, that is the number of atoms, oxygen atoms only. So you need to read these questions very carefully, grade 10s. I know I've said this before, but I'm going to say it again, because that is how you get caught out. That is by not reading properly. Okay. Question 11 asks, okay, yeah, it's asking for what mass of solute was needed to make up the solution. So it gives you the concentration of the solution, the zinc chloride solution. It gives you a backdrop, some foundation information. And now it wants to know what was the mass of the solute, the mass of that powder needed to make up the solution. If the volume used was 90 centimeter cubed. So convert. Make a note before you do anything, convert. Secondly, identify your essential question. Thirdly, write down your formula. Okay, and there's a lot going on here. I understand that. I wrote quite a few extra notes, but just bear with me. Okay, once you have done that, once you've done number 1 and number 2, when you have your mass, now you're going to have there's going to be a 2-step system here. Okay, because it's asking for the mass. So you have to work backwards now. The first thing you're going to do is you're going to get your moles using your concentration formula, because that makes sense. Given the information you have, it just makes sense to use a concentration formula. Okay. Once you have that volume, the number of moles, the moles value, you're going to use that value in your mole formula. So you're going to take the moles and times it by your molecular mass. And you should get an answer of 7.37 grams. The last question on page 14, question 13, asks, what volume of water would need to be added to 12 grams of sodium dichromate in order to make up a solution with a concentration of 2 moles per decimeter cubed. Now, what am I going to do here, guys? What is the first thing I'm going to do here? Once again, you've identified everything you need to in your little question. You've identified your essential question, which is what is the volume? Starting for volume, okay, needs to be added. You have identified your mass. You have written out your formula, okay, and it's given you the concentration. So I'm going to now, instead of like in the previous situation, it was asking for the mass of the solute. Here it's asking for the volume. So what am I going to do here first? I'm going to work out my moles first. That's the first thing I'm going to do. And then I'm going to get an answer of 0.046 moles. That answer there is very, very important because you're going to use it. You're going to use that in the formula using the desired concentration, which is 2 moles per decimeter. So from that, use our concentration formula, we manipulate it, okay, we've got our moles, we've got our concentration, and you should get an answer of 0.023 decimeters. Okay. So I really hope you guys are getting this. I hope this is not that difficult. Once again, if you are stuck, please drop myself or Mr. Ginsberg a message and we will gladly help you out in any way.